It's a great journey. And in a technical question, I tend to over explain a bit because that is my lane. That is what I do, is build architectures and code them. So please pardon with me. And I'll take you through it. I'll try to explain with some diagrams as well. Some of the docs that I had back in the time, I scrapped them out, and some handwritten diagrams as well. And I think it will be good enough for you to understand what we did and why we did it. Okay, let's go.
After we clear SCF, we had a team meeting with the technical department, and they gave us the idea of integrating the Stellar Disbursement Platform actually into our product to support batch payrolls. Initially, we were going through contracts and subcalls, not directly subcalls, but yeah, multiple contracts to pay to multiple recipients, but that was very inefficient. So they gave us the idea of incorporating Stellar Disbursement Platform. This was something that they had launched at that point of time, and I was so happy to hear that they already have a platform that will satisfy all our requirements. We were Gucci in a sense, but when we went on to integrate this, then came the actual nightmare. So all our team at that point of time, that was me and one other guy. I was the technical guy in the team, so all the coding and the architecture had to be done by me. So I was ready with Rust. The complete ecosystem was in Rust. So the one contracts were to be written in Rust, and I was very happy that I was strong in Rust and I could do it. But when I went on to integrate SDP, it was entirely in Golang. So that was an issue. Now, who to ask is the major question in such a scenario. So what I did a bit of study of Golang to understand the code, and then went on to find out how this entire thing works. So what happened? Stellar Disbursement Platform was designed to work for a single organization. If you and I were to do batch payments, we can just download the Docker image, deploy it, and yeah, use it. So for a single tenant, it worked well. But our idea was to support multiple tenants at the same time. And this was something that this entire ecosystem hadn't designed for, and we had to do it from scratch. So what we did, Stellar Disbursement Platform consists of three main services: TSS, the transaction submission services. My handwriting is pretty bad, and I'm sorry. Then comes the Kafka queue and the event management service. This is basically when someone initiates a batch payment to how to handle the message queue and all those things. And the third part was a very simple authentication system on Postgres. Now, this worked very well for a single organization because you had everything in your control, and this was centralized. So the TSS had a wallet address that would hold your funds, and that was completely detrimental for us because we completely designed the product to be decentralized, or at least in a way that we never hold funds from the user. So everything has to be redesigned from scratch. Now, what I did is I broke down the entire code of SDP, found out all these sections, and did two things. Realization. What we realized was this was never designed for a single entity, so we had to make it a multiple entity system. What we had to do is remove the centralization. We had to somehow create an abstracted localized account for each organization inside the submission service so that their funds are never with us and already in the custody of the submission service and logged in there until the batch payment is complete, and all the retries are also complete in case of some partial failure. So yeah, logged out the funds from our side to the user side, giving them the complete control. I rewrote the entire Kafka queue because what was the major problem in SDP was it took the payment lifecycle from payment created to done as one step. So if someone had created a pay, they click the pay button, the transaction will automatically show green and say done. Whether it was actually confirmed or not is a backstory. So what used to happen is you create an intent of payment, it had multiple recipients, it will then go into the Kafka queue, it will split them into a single transaction and then feed to the TSS service, which will then send to the chain. So at this point, it used to say done, but that is very irresponsible from a system, especially a financial system. So we had to redesign this entire queue. And what I did was added an atomic state to each transaction, which was linked to an SSE. So whenever the state of this atomic transactions packet changed, the SSE used to emit that event to the client. So real-time changes were displayed to the user on their transaction. So if they paid, say, 10,000 people, you can actually see at what point of time where the transaction is. So this was all about observability for the end user. Now, second thing was it was broadcasted as 10,000 transactions. Now, this word encapsulates everything. Like it attracts every organization. Like you can make 10,000 transactions from the Stellar Disbursement Platform. But the issue was this was the amount that one deployed unit can do. Okay, so basically, if I had one SDP cluster running in my GCP, it could send 10,000 transactions on parallel with the support of their ecosystem. But if you are a single organization, good for you. But what about multiple organizations? If I even have 10 clients that pay, say, 1,000 people, I can easily hit this limit. And let me tell you the story. What transaction submission service does, it briefly takes a transaction intent from the Kafka queue, gives it to an account, a Stellar account, and then broadcasts it to the chain. Now, SDP is configured to have 8 of these accounts. Okay, so you can at max send 8 transactions, and a Stellar ledger closes at 5 seconds. So it's about 1.6 to 2 transactions per second. Okay, so near about 2 hours you'll take to complete a 10K transaction. And the fundamental issue was until unless a batch was completed, you cannot restart a batch. So this concurrency issue was a very big issue in SDP, and I had to fix that. So what we did, I redesigned the entire transaction submission services. And to be very clear, we worked on SDP 4. And when we got over with SDP, we had an SDP 5.1 release, which actually took the improvements that I had made into a proposal. So what we did was, if one channel account can send one transaction per second, you might think you just say, take 10,000 channel accounts. But every channel account has a 2 XLM barrier to be kept as a reserve fund. So you have to spend 20,000 XLMs, and that is not a good thing. So what we did is, on an optional range, let's keep 8 channel accounts that the SDP comes with. Let it not call the contract or the transaction directly. Let it call the contract subcaller. Now what this is, when you go through Stellar's documentation, on a very short note, there is written Stellar supports authorization trees. It's a 2-3 paragraph only statement written in the official documentation. And when you go through the talks completely 3 to 4 times, then you realize there's a solution there. What it does is, if you have a fleet of contracts that can pay to, say, 15 transactions per second or 15 people at once, one contract can pay 15 people. One channel account can invocate a subcontract caller, which uses authorization tree to then call 15 or 16 such contracts. So you can effectively multiply the amount of transactions that you can do. So now your one transaction call from a channel account can support these many parallel execution calls. So what did this was, it reduced the complete stress from our TSS service and diverted it to the actual ledger. So now the blockchain had to work more, not us. And what we did, the stress testing, 70% of the ledger is most of the times empty on Stellar, because transactions are compressed and atomized so effectively that the ledger remains unconsumed. You can effectively send these contracts multiple calls and it works fine. So we were able to scale and throughput the transactions from this 1.6 to 2 transaction per second to 120 to 200 transactions per second with the help of these accounts. So this is what is now effectively used in the SDP as well, in a different way, but the core idea is similar. This was the improvement there. We talked about how we reduce the central custody of funds by using isolated accounts, how we improve transaction services by introducing authorization tree in the entire picture. Now third came how you would give the authentication plus authorization to orgs to this system. Okay, so effectively what happens in SDP is you have a Postgres server on your local, and it keeps your SK identity token. It's your Stellar Treasury identity token, and through which you can control your entire organization. But this was not good enough for the orgs because you cannot just ask them to keep their tokens in their hands. So out of bounds for them and very difficult for them to handle it. So what we did is designed the entire AWS KMS system into this Postgres-based service, and we routed this ID to be dedicatedly derived from this KMS identity in their hardware management system. So this key never left AWS, and at the time of signing, it used to derive to access those isolated accounts for funds. So this was done to effectively provide a complete decentralization to the funds, custody, and authentication system to improve the throughput and transaction exactly in the TSS, and to reduce the burden on channel accounts, and to utilize a solution that was entirely there in the ecosystem, but nobody knew how to do it. And this integration sounds pretty easy, TSS plus auth trees, but this is not very easy because this runs entirely on a Go backend, and this is a completely a Rust contract-based system. So you need to build adapters in between to manage the queue and calls. So everything there was designed by me. Now, I don't want to bore you with too many charts because those are too big to understand. Like, while I cannot show you the code because that is proprietary right now, but this architectural documentation is entirely my design. So I designed the entire authentication service. Uh, we created a job queue with KMS as well, incognito, to keep the keys safely. The initial Kafka service that Stellar Disbursement Platform used to have was not that efficient to manage multiple teams at the same time. So we had to create an ingestion service as well. And I told you already about onboarding and funding services. This is the more detailed version of that. Orchestration engine is how a job is created. It's basically when you get the intent and breaking down the transaction and then submitting it to TSS. Not a very technical thing. The most important thing was execution engine, because here lied the every thing that could go wrong. So if the auth tree invocation calls went bad, where did the funds go? So we built a resweeping service that can sweep all the channel accounts dedicated to a tenant so that they can get your funds back. And if the contracts were locked on with funds as well, you can call your auth tree invocation call tree and get your funds back. So funds never got lost. That was the one thing actually I also designed. Got completely out of my mind. I want to just show you the difference what we compare at that point of time. Why we built this microservice kind of architecture for TSS? Because monolithic had a very low customization rate and upgrades were very difficult. We were trying to move to multiple ecosystems, so supporting multiple chains required us to build the SDP for those chains from scratch. But with this microservice architecture, what we could do is just improve the onboarding and execution engines as per the chain, and then integrate directly to the core ecosystem. So we don't have to build the entire system for all the other chains. Throughput increased. We got like 200x increase on throughput. We could now pay, say, a million users as well at the same time, and it will effectively go through all the services. We increased the adaptive failure rate, because there are times when the network would go down and the original SDP, you don't get an error or a notification for your partial transaction going bad. So we introduced that as well. The system retries 3 times, and if it doesn't go through, it gets back to the user and gets that fund back to their main wallet. So you don't have to worry about losing your funds there as well. And because we were making it a multi-tenant SaaS, so we had to make a microservice architecture because we cannot just be supported by a single tenant. So this is what the entire thing I designed was, and this is something about the auth tree I made right now because I wanted to explain it. So it's simply instead of just calling one time, you can just sub invocate your calls to multiple contracts. In that way, you can increase throughput without putting on burden on a single unit. So this was a very ingenious solution. I'm really very happy to show you this because it was accepted by them as well, and it was something that was there in the ecosystem, but nobody had any idea of how to use this. because it was a core Rust based implementation, and I had to make an adapter in Go for this as well. So yeah, this was very good, proud moment. And this is the complete like overall architecture, how we work on payzoll. This is all the engines. It was used to like derive the overall structure for other chains as well. So yeah, this is how we built payzoll's complete back and then technical support. I mean, I myself was solo at that time. So this is what I architected, researched, drawn, coded, failed, then debugged, then did again. Worked very technical in this product, went to great depths, understood an entire ecosystem whose docs are very, very large. And it was an interesting journey. Yeah, this is the thing that I've built and shipped. It was very interesting, to be honest. It was complex. It failed a lot. It got broken many times. Many of the components were not working, and somehow, some way, with multiple trial and efforts, it did work, and now it's live. So yeah, this is it. And I think I did not bore you too much because yeah, I get very over explanative when I explain these technical things. I'm sorry for that, but I hope you like it. Thank you.